How would you do this integral? The integral of 1 over 1 plus sine x. One of my students asked me this question the other day. For context, I am a private math tutor. That's how I've been keeping busy for the past 16 years or so. But this was how I showed my student how to do this integral. We actually used conjugates. The nice thing about conjugates is that when you multiply an expression by its conjugate, you can do so quite easily using the difference of squares pattern. Furthermore, you get perfect squares, which will be very nice for trig functions because then we can employ the Pythagorean identities. So what we first do is we multiply the top and bottom of 1 over 1 plus sine x by the conjugate of 1 plus sine x, which is 1 minus sine x. Doing so and simplifying, we get 1 minus sine x over 1 minus sine squared x. Notice 1 minus sine squared x is actually just cosine squared x from the Pythagorean identities. Now we have 1 minus sine x over cosine squared x, but we can split this into two fractions. 1 over cosine squared minus sine over cosine squared. And notice these can now be rewritten as secant squared minus secant tangent. Thus, all we have to do now to evaluate the integral is we have to integrate secant squared minus secant tangent, both of which are very trivial to integrate. We just get tangent minus secant, plus c, of course. Can't forget about the c. Now, for my more advanced students out there, we could have also used the Weierstrass substitution or the tangent half angle substitution. This substitution here, t equals tangent of x over 2. I'll let y'all try this out on your own, but if you do so, you're going to get a different expression for the antiderivative, but it's still equivalent to our original antiderivative of tangent x minus secant x plus c. In fact, if all goes well, you should actually get this from the Weierstrass substitution, negative 2 over 1 plus tangent of x over 2 plus c, which is equivalent to this expression in terms of cotangent, and both of those are equivalent to these expressions in terms of sine and cosine. And it's also not too difficult to show that all 5 of these trig expressions are equivalent to each other using basic trig identities. So I'll leave that as an exercise for y'all. All right, with that, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch y'all in the next one. Take care.